Hello and welcome to the continued video on area, volume and perimeter. Firstly, what we're going to look at is we're going to look at a standard shape. So I'm going to start off with a rectangle. So if we've got this rectangle here and I wanted to look at what the perimeter of this was going to be. Let's say for example that's 3 and that's 4. Now when you're working out the perimeter, okay, I'll just put P for perimeter, what you do is you add together. So you add everything together. But what you also need to, it's not just a matter of 3 plus 4, but also what you have to do is you have to make sure that you add the missing sides. Okay, so you can see here, what I'm going to do to work this out, I'm going to go 3, add 4, add 4. Okay, so when I add all those together, that is going to give me 6, 3 add 3, and 4 add 4, which equals 8, which gives me 14. Now, these here would have a units of measure, so they'll probably something like 14 centimetres. So, when we're actually describing the length, we describe this as 14 centimetres. Now, as you can see here, there's no additional square or cube with perimeter. And that's because perimeter is just measuring a straight line. So whenever we've got anything to do with perimeter, you've just got to remember it's the line around the edge. And all you've got to do is add up all of those sides. Now, let's say for example, okay, let's just say for example, we have got algebra on here instead. So you've seen previous videos on how to solve equations and how to collect like terms. Now let's say for example this here is 2x and let's say that here is 3x plus 1. Now if I'm working out my perimeter, what I need to do first is I need to add in the missing sides. So here is 2x and here is, I keep on doing this, just bear with me a second, let me get my slide back, thank you. This one here is going to be 3x plus 1. So what I'm going to do now is I'm going to, I'll do that in a different colour. What I'm going to do here is I'm going to show you how to collect, how you would show this as an expression. Now as you can remember, an expression is just when you're adding up the terms and the numbers when you're just adding the terms and the terms of with the variables and you're adding up the numbers. So the aim is to make an expression. Now if it was an equation, your sum would have an equal sign in it. So I'll show you in a minute how sometimes perimeter is asked in the exam. So in this case here we've got 3x plus 1, okay? I have got another 3x plus 1. I have got a 2x. And I've got another 2x. Okay. Now let's say I was just to add this up like a normal sum. So let me add the numbers up first. So 1 add 1 equals 2. Okay. And what I'm going to do now is I'm going to add up how many x's I've got. So I have got 2x add 2x is 4x. 3x plus 3x is 6x. So 6 plus 4 would leave me with 10x. So the expression for the perimeter is equal to 10x plus 2. Now, all I've done there is I've just collected the terms. Now, sometimes in the exam, they add additional questions. So they might say something like, the perimeter is equal to, let's say for example, 22 metres. So let's say it just says the perimeter is equal to 22 metres. So what I'm going to do is I'm just going to look at this equation, this expression here, and I'm going to make it into an equation by putting it equals 22 on the end. So what I'm going to do now is I'm going to solve this equation. Now, one way of solving equations, and this is the way that I do it, what I like to do is I like to create what's known as an opposite column. And let's say, for example, here, but use the method, but what I want you to do is use the method that you would normally use, the method you've been taught by your teacher. Don't try at this time, later in the day, try and understand how I'm solving this equation. Concentrate on how you would solve the equation. So, if I've got 10x plus 2 equals 22, the first thing I do is I look at what I've got. So I've got plus 2. So my opposite of plus 2, my inverse, would be minus 2. And I've also got 10 times x. So if I'm looking at 10 times, what's the inverse to times 10? And that will be divided by 10. So I'm going to start off with 22. So I'm going to bring down this number here, this 22. And I'm going to go 22, take away 2. And that gives me 20. I'm then going to take the 20 and I'm going to go 20 divided by 10. And that gives me, for example, that would give me 2. So therefore, x is equal to 2. So what they might require you to do is then go back to your original equation and sub in the values to see if it's correct. So what I'm going to do is I'm going to check whether this is correct. So if I had 2 times 2, for example, that would be the same as 4. So this side here and this side would be 4. So in total, them two sides would be 8. Here, when I've got 3 times x, so 3 times 2 is 6, plus 1 is equal to 7. So this side here is equal to 7, and that side there is also equal to 7, because those two expressions are the same. So 7 add 7 is 14. 14 add 8 is going to give you 22. So therefore, your equation's correct. So what I'm going to say now is, why don't you have a go now? So sorry, just let me open up a new one. So let's start a new drawing. So I'm going to give you a perimeter to work out, and I'm going to give it you with algebraic expressions on the side. So it's going to be a rectangle. This here is going to be, let me just make this a bit smaller. This is going to be x plus 1, and this is going to be 4x plus 3. So what I want you to do now is I want you to write that, and I want you to have a go at answering this question now. Now, if you're watching this after the live stream, what I want you to do is I want you to pause it and have a go at solving it. So I'm just going to go over the steps that you'd need to do to solve this. So the first thing that we're going to look at is we're going to look at solving. So we're going to look at what we do first. So firstly, we add together. Okay, so the first thing you're going to do is add them all together. Then you're going to create an expression. Okay, so you collect the terms by adding the terms together, you create an expression, and then you set it equal to the perimeter. So you create an equation, so you make an equation. Okay, so they're the steps. You collect the expression. So I'm just going to go and have a go at working these out now. Okay. So I'm going to start off with this one here. How I'm going to look at this. So I have got x plus 1. So x plus 1. I should have another x plus 1. Remember what I said before, make sure you add the one on the other side. And here I'm going to add now my 4x, add 3, and my other 4x plus 3. Now, if I was to add all the x's up, I've got 1x, 2x, 2x, add 8x is going to again leave me with 10x. And then this time I've got 3, add 3 is 3 add 3 is 6, add 2 equals 8. So it's going to be 10x add 8. Now let's say, for example, the perimeter of this was 48. So let's say the perimeter is equal to 48. How would we solve that then? Right, so if this was the case and this was the perimeter, okay, what I'd do is I'd start off with my equation. So 10x plus 8 equals, back, sorry about this. Sorry. So what I'm going to do is I'm just going to set this equal to 48 here. So the first thing I'm going to do is I'm going to take away the 8. Okay, so I'll take away the 8, which is going to leave me with 40. And then I'm going to divide the 40 by the 10, which leaves me with 4. So therefore x equals 4. And as you can see, that would be 5. That side there would be 5. 5 add 5 is 10. If this was 4, that would be 16 add 3, which gives us 19. 19 add 19 equals 38. 38 add 10 gives us 48. Yeah, I'll just give you a few minutes to write that down. And what we'll have a look now is we'll have a look at how we would make this, how we would work this question out if it was asking a similar kind of question for area. So I'll run through the basics of area and then I'll move on to how you'd solve it if it was algebraic. Okay. What we're going to look at now is I'm going to now look at a similar rectangle. So I'm going to start with this, and I'm going to look at this as if it's area. So I'm going to imagine that this side here is equal to 4 and this side here is equal to 6. That there would be 4 centimetres and this here would be 6 centimetres. Now when we're finding area, so this here what we're looking at now is area. When we're calculating the area, what we do is we times the amount. So what you're going to do is you're going to take the two lengths that you've got and you're going to go 4 times 6 equals 24. And the unit of measurement this time, it goes from being centimetres into what's known as centimetre square. Now the reason why it's centimetre square, because it's measuring how many squares fit into this shape. So let me kind of show you this a little bit visually. So what I'm going to do is I'm going to split this rectangle here into, let's imagine, I know they're not a centimetre, but as what you can imagine would be into centimetre squares. Okay. So you can see there, if I was to count how many centimetre squares I have here, I'd have 4, 8, 12, 16, 20, 24. So because you're actually counting squares by timesing, all you do is you leave your units of measure as centimetre squared. Okay, so looking at this, what we're going to look at is we're going to look at how to solve this algebraically. So I'm going to start off here with x plus 2 and 2x plus 1. Now, as you can see now, this is going to be times in algebra. So what we're going to do is I'm going to add brackets to these. So by adding it into brackets, as you may remember, this will turn it into expanding to brackets. So I think there was a video last week on how to expand brackets. So what I'm going to do first is I'm going to look at multiple methods on how to work this out. So depending on how you've been taught in class, I'm going to show you 2 methods. So the first method, okay, I'll do that in black, is using a box. Okay, so what you do is you use a box like this. And what I'm going to do is I'm going to put my x plus 2 here, okay, and I'm going to put my 2x plus 1 here. So the first thing what I'm going to do is I'm going to go 2 times x, 2x times x. So because I've got 2 x's here, it means that I'm going to have an x squared. And I'm going to end up with 2x squared. Then what I'm going to do is I'm going to go 2 times 2x. So because it's just the numbers, I'm just going to times the numbers together this time, which is going to give me 4. So it's going to be 4x. Coming to this point here, it's going to be x times 1. And this time what I'm going to do is I'm going to call it 1x, because sometimes, even if you just put an x, sometimes when you're adding them together at the end, if you don't put that 1 in, you forget to count it, or you might be tempted to make it into a square. A lot of people do that. It's just an easy mistake, because you see that you've got 2 x's together and you times them together and they end up square. So what I'm just going to do is I'm just going to put a 1 there, so you know that when you add them together that you're going to end up with 5x. So the next thing that we've got here is we've got 1 times 2. So 1 times 2 is 2. So what I'm going to do now is I'm going to get all these together. So what I'm going to start off with, I'm going to start off with this one here. So this one here is 2x squared. And I'm going to circle this corner here, which is 2. It's a positive 2, so it's going to be plus 2. Now what I'm going to do is I'm going to add these 2, so it's kind of like a peanut shape almost. And I'm going to count how many x's I've got here. So 1x, add 4x, gives me a total of 5x. So my expression for this would be 2x squared plus 5x plus 2. Now, if you wanted to use FOIL, so a lot of people use the FOIL method to solve. I think the majority of people do use this. This is for someone who's more visual, who likes a structure to answer. So if you like a structure to your answer, this is a really good one, because this one that we've just done, because it puts everything in a place. Now with FOIL, sometimes these are the people who just can see the more abstract side of maths. So let's have a look at this. So I'll do this here. So I'm going to start off with x plus 2, and I'm going to add 2x plus 1. Okay. So what I'm going to do first is I'm going to times my first 2 brackets. I'm going to draw x times 2x, which gives me 2x squared. Then I'm going to do, so I do my first, and then FOIL, the next one stands for outers, so I'm going to times these 2 together. So I'm going to go x times 1, which gives me 1x. Then I'm going to times in my innies, so it's going to be 2 times 2x, which gives me 4x. And then I'm just going to times my last two together, which is my 2 times 1. Okay, and 2 times 1 gives me 2. Okay, so again, this is just the same as before. You've got your 4 and you've got your 1. So what I'm going to do is I'm just going to rub these out. You add 4 and 1 together and you end up with 5x. Okay, and you can see with this method, with the fold method, it kind of like makes kind of almost like a face shape. So some people remember that they make a smiley face when they're using foil. So this is how to use algebra to find out the area. This is finding out the area using algebra. What I'm going to look at now though is I'm going to look at something just a little bit different. We want to look at area just a little bit more, but I want you to think about, what do you know, what formulas so far do you know for area? Okay, so if I'm looking at example, my first type of area that we're going to look at is, we're going to look at the circles. Now, you've done a video on this. Do you know what the formula is for finding the area of a circle? Okay, so this here is area of shapes. Okay, so that's what we're doing now, area of shapes. So to find the area of a circle, okay, we use the formula pi times radius squared. For those of you who struggle with radius squared, it's radius times radius. The next one is a triangle. Okay, so we're finding out the area of a triangle. For foundation, you will just use the formula half times base times height. Some of you who've previously done who've done the higher paper, you might be used to the sine rule, so half times AB times sine C. In this case here, you wouldn't need it for a level 5 for foundation, so I just want you to concentrate on the area of this formula here. To find out the area, the next one that we're going to look at is, we're going to look at area of quadrilaterals. And what do I mean by quadrilaterals? Now, quadrilaterals are four-sided shapes, and we have quite a few of those. So the first one that we have is we have the square. So the square is probably the one that we're more familiar with. The properties that it has are all the sides are the same. It has 4 lines of symmetry, and it has a rotation of order 4. The next shape that we've got is the rectangle. Now the rectangle, again, very similar to the square. All its angles are 90 degrees. It has 2 sets of parallel lines, so these are has 2 sets of parallel lines, and all its angles are 90 degrees. It has 2 lines of symmetry, and it has a rotational symmetry of order 2. Now, by rotational symmetry, what I mean is, how many times does this shape fit into itself? So, let's imagine I've got another one of these. Okay. So, if I was to look at this shape here, and I was to take make another shape like this. If I was to spin it around, okay, I could make it fit into itself twice. I don't think it's going to let me spin it round for some reason. No, it'll make it bigger, but it won't let me spin it round. Okay, I'll get rid of that. So, the rectangle and the square are the two that are the most similar, because they have very similar properties. Okay. The next one that we have is the trapezium. Okay. Now, the trapezium is a trapezium because it has one set of parallel lines. And by parallel, it's like train tracks. Okay, sorry. It's not letting me type parallel. It has one set of parallel lines. So you can see here. Now to work out the area of the trapezium, you use the formula half times A plus B. Now A plus B, this line here at the top, the smaller of the two parallel lines is A and the larger one is B. So you find out the length of those two, add them together, and then you times it by the height. And that's how you work out the area of a trapezium. Now if you're going back to working out the area of the square and the rectangle, to find the area of the square, it's basically length times height. So if this side was 2, for example, and that side was 2, it'd just be 2 times 2. To work out the area of this, again, if that was 2 and that was 4, it'd be 2 times 4, which would just give us 8 centimetre square. But we've got some other quadrilaterals as well. Now the other quadrilaterals that we've got are known as the parallelogram. Okay. Now the parallelogram is very similar to the rectangle. Okay. So the parallelogram is similar to the rectangle. And again, to work out the area of this, it's just the same. It's length times height, or base times height. And this is an example of how it works here. So let's say, for example, this was 5 centimetres. The height would, and this here, so this length of this side here was 2. Let's say, for example, the height here, when I worked it out, was 1 centimetre. Okay, and that's 5 centimetres. Now the height is this measurement here. It is the measurement between the parallel lines. Okay, if I was working out this and I was using 5 as my base, I'd be looking at this height here, from there to there. So it's basically from this point, from this parallel line to this parallel line. Sometimes we need to use trigonometry and Pythagoras to work out the area of these. So I'll show you that in a moment. I'm going to look as well, the other thing that we need to learn, what we need to know how to find the area of, is how to find the area of a rhombus. Now, just like the parallelogram, I'm sorry, that doesn't make that a little bit more like a rhombus. A rhombus is very much like a square. All its sides are equal. Okay. Okay. And it's like the parallelogram as well, because its angles aren't 90 degrees. So the opposite angles here, so this angle here and that angle there, are always the same. And that angle there and this angle, the two larger angles, are also the same as well. So I'm going to look at how to work out, firstly, a trig question. So we're going to look at finding the area let's start that again. So we're going to look at finding the area Sorry, I just want to find a normal pen. I don't know what I've managed to do. That's better. So what I'm going to look at is I'm going to look at finding how to find the area. So we're going to look at finding the area of a parallelogram. So the kind of ideal kind of question that we want to see in our exam is one that doesn't require a lot of work, especially when you're working out areas and you've got to try and remember formulas. So here is our parallelogram. Now in this case we're going to be given the height in this case. So I'm going to imagine that the height of my parallelogram is 5 centimetres. And I'm going to imagine that my base here is going to be 10 centimetres. So if I was to work out the area of this is just going to be a simple 5 times 10 base times height equals 50, and because it's a 2D shape, remember it's 50 centimetres squared, okay, because you're counting how many squares fit into that shape. But what I'm going to do here is I'm going to also give you an example of how potentially a question could look like in the exam. So again, this time I'm going to do this one in red. Okay, this time we've got another parallelogram. Okay, and so with our parallelogram here, we know it's going to tell us that this length here is 10. But then it also tells us that this length here is 5 centimetres and the base is this. But what it doesn't tell us is it doesn't tell us the height. Okay? The height, this bit of information here, is missing. So if you've done this, you can use a formula to work out this, but that's the kind of formula that you might get on a higher paper. So I'm going to show you how you might be expected to use trigonometry to work this out. So I'm going to imagine that in this question here, it tells us that this angle here is equal to 60 degrees. So let me draw it this longer. So I'm going to do a bigger example of this triangle. So to find the height, I'm going to have to split this in two. Now, this parallelogram has an angle of 60 degrees. Okay, and we know that this here is 5, and we're trying to work out this height here, so that's going to be my x. Now I can't use the 10 at all, because the 10 here it's only part of 10. So if you look here at where that is, we don't know how far, because we know that's 60 degrees, we can't necessarily cut that. So what we're going to use is we're going to use trigonometry to solve this. So I'm going to start off with 5x. I'm going to start off with this. So the first thing when we're doing trigonometry, we start off with the rules. So the first thing we do is we label. We then use SOHCAHTOA. Okay. Then once you've used SOHCAHTOA, okay, I'm going to just give me a second. I'm just going to erase everything off this side so I can do my working out here for this problem. Okay, so you label your triangle, you then use SOHCAHTOA, and then you solve. So your last step is solve. Okay. So I'm going to look at this trig triangle now. So the first thing I'm going to do is I'm going to label my sides. So I'm going to start off here with my longest side. That's going to be a right angle. So this here is going to be H. If that's H, then I go to my angle, and the one that's next to the angle is A for adjacent. Then going from there, you then go to your next one and you label that O for opposite, because it's opposite the angle. What you do then is you then highlight what the printed text. So sorry, just let me get rid of that for a second. let me look at this. What I'm going to do is I'm going to imagine I had a highlighter. I'm going to highlight this, and I'm going to highlight that there. So if I was looking at my printed text now, I highlight the 5 and the X because they will be on the question. I'm then left with a H and an O. So if I was looking at sock or tower now, I'm going to look for which one of these 3, sock, cat or tower, has an O and a H in. So if I look here, sock has an O and a H. So because it has an O and a H, I'm going to use the sign. I'm going to use sign to solve that. So it's telling us that sine x is equal to opposite divided by hypotenuse. So what I'm going to do is I'm going to draw a trig triangle. Okay, this might be a new concept for some people. For any of my students, you've seen me use this dozens and dozens of times. So what I'm going to use is, when solving using this, I'm going to start off with sin. So I'm going to write sin here. So inside here, that's going to be sin. This is S-O-H. So whatever is, if I'm looking now at my opposite, that's going to be an X. That's what I'm finding. So I'm looking what the opposite's going to be. Here, I've got my, so this says sin. And if I'm looking at my H, that's going to be a 5. And then where the sin is, what I'm going to look at is I'm going to look at the angle. So you always sine the angle. So as you can see there now, I've actually got the equation that I'm going to actually put into my calculator. So in my calculator, I'm going to type in sin 60, remembering to close the brackets, times 5. So sin 60, close brackets, times 5. Now when I put that in my calculator, you might be required to press S to D, but when you put that in your calculator, you get this number here. So you get 4.3301. Now I'm going to round this to 1 decimal place. Okay, so that's going to leave me with 4.3. So this measurement here is going to be 4.3. So going back to my original question, my original problem. Sorry about this. Going back to this original problem here, we now know that that is equal to 4.3. So if I'm going to work out what the area of my parallelogram is going to be, so let me redraw my parallelogram here. We know that the base is 10 and we know that the height is 4.3. So 10 times 4.3 is going to give us 43 centimetres squared. Okay, I'll just give you a moment to copy that up. Okay, so that was how to find the area of a parallelogram. Now I'm just going to do an example of a trapezium. So how to use the formula for a trapezium. So can you remember what that is? So a trapezium has a pair of parallel lines, and it has a pair of parallel lines and then 2 other random lines. Now a trapezium doesn't necessarily have an order of rotation. It has an order of rotation of 1, so it only fits into itself. But what we're going to look at now is I'm going to look at how to work out this. So I'm going to imagine that this length here is 5 and this length here is going to be 7. And the height, okay, the height is going to be 6. So, remembering my formula from earlier, it is half times a plus b times 6. Oh, sorry, times height. A bit eager to put the height in there. That would be height, not 6. So, putting that into the formula, I'm going to go half times a plus b. So, that's going to be 5 plus 7 times 6. That looks more like a b. Right. So, 5 plus 7 is 12. So, half times 12 times 6. So if I was to work out what 12 times 6 was, that would give me 72. And if I was to half 72, okay, divided by 2 is the same as a half. Remember that all a half is just looks like a divide sign, doesn't it? So all fractions are a divide. Look how similar they are to the divide symbol. That's where the number 1 goes, and that's where number 2 goes. So it just means 1 divided by 2. That's going a bit off topic there. But going back to topic, we're going to do 72 divided by 2, which is 36. Okay, so if I'm looking at the area of this, it would be 36 centimetres if this had a unit of measure on, which it doesn't have, centimetres squared. Okay, so what I'm going to do next is I'm going to quickly go over volume. Let me have a look. I'll just make a new one here. So I'm going to quickly go over volume. Oh,